Assalamu alaikum class. I'm your teacher Nurul N, and today we are going to basically study the next topic from the chapter 3. We have covered most part of this chapter already, and from now on the later or the subsequent topics would be taught through this online medium of videos. So moving on, I'll just give you people a recap of what we have studied and what is the remaining part of this chapter. The first thing is that we have covered the present and future values of single amounts, and we have also covered annuities, ordinary and annuity due, both type of annuities along with their present and future values. There were four different formulas, and you basically make a slight change in annuity due formulas. You have to just remember or retain the formulas for ordinary annuity. Fine. The third thing is we quickly skip this topic in the class as well. You cannot calculate basically the future value of for perpetuities. Perpetuity means same amount of cash flows occurring over infinite period of time or for infinity. There is no time period or maturity for perpetuities. That's why we cannot calculate the future value, but we can somehow calculate the present value of perpetuity by using a single, or a simple formula, which is cash flow or interest or any other payment that you are receiving or paying divided by the interest rates. Fine. From here on, we'll move on towards the fourth topic, which is what happens or how your formulas basically change when compounding is happening or discounting is happening for more than once in a year, and what is meant by effective annual rates and how these are calculated. In today's video or in this particular video, we'll cover this fourth content of this particular chapter. I have basically I don't have the facility of a whiteboard. That's why I've made these particular slides for you people for calculation purposes as well. Furthermore, we'll study through slides as well. We'll be left with one topic from this chapter, which will be coming in the second part of or in another video. Fine. So, moving on, semi-annual and other compounding periods. That means what happens when compounding instead of annual compounding happens semi-annually or quarterly. That means your annual accounting rate or per annum rate is applied not once, but for semi-annual it will be applied twice for every 6 months. So for that, how your formula or how you can calculate the future and present values, you have to make a slight change to the existing formulas. How you can do so, I'll show it to you people. You might find it difficult to learn through these slides as so many abbreviations are involved, but I'll show it to you using this slide. Here I have taken an example as well, but ignore that example. You can just look at this formula I have written over here. Pardon my writing, then again it's not a whiteboard, that's why. You have to make a slight change to the existing formula. Remember, you know the formula for single amounts and the future values. That is basically amount multiplied by 1 plus I raised to power n. You have to make a slight change over here. You have to include this compound factor, which is denoted by m. You have to divide your interest rate, the annual interest rates, by m, and you have to multiply it with the number of years. Fine. I'll show it to you with an example. Here we have an example for semi-annual compounding. uh, Semi-annual compounding, I have taken an example of 500,000 rupees. Suppose you invest 5 lakh for 5 years at 10% rate. So far it's the same question that you have already solved, but the change is over here. Suppose that the rate of interest is applied semi-annually. That means not this per annum rate will not be applied once or after a whole year. That this particular rate will be applied in two parts. For First it will be applied at the end of 6 months, then again at the end of the next 6 months. That will change your calculation a bit. You have to use the same future value calculation, but again with a slight change. You'll divide your interest rate by the compound factor. For semi-annual compounding, you have to consider this m is equal to 2. That means the compounding is happening twice a year, not once. Because of semi-annual, every 6 months, your rate will be applied two times. So m here will be 2. Fine. Same goes with quarterly compounding because there are 4 quarters in a year. Your rate will be if your rate is applied 4 times in a year, this m will be denoted by 4. Fine. So n is again the same. It's the number of years which is given in the question. It's 5 years, and m again will be 2 for semi-annual. Again, this m will be taken as 2. You can see it here. I've put all or inserted all the values in this formula. Amount is 5 lakh. One is again the same as the earlier formula. 10%, I've taken 10% without the percentage, and I've taken it in decimal form, 0.10, and I've divided it by 2, which is m for semi-annual compounding. It might change to 4 if it's quarterly compounding, and it may be 12 for monthly compounding if it's written in the question. You have to specifically see it or carefully read your questions for compound factor. Fine. So I have multiplied the number of years by 2 as well, because the number of periods here will increase, not merely 5. That will become 10 now because your rate is applied 10 times in 5 years. Fine. So calculating it, through your calculators, you will get the final answer of 8 lakh something. It's 8,14,447.31. You have to retain your answer to two decimal place. I've already told you this in class as well. So your future value will be 8,14,447. If it wasn't semi-annual compounding, I've taken it as an abbreviation. SAC stands for semi-annual compounding. Under annual compounding, you might be getting your answer a little lower. That would be 8 lakh 5,255, because compounding periods are increased. That's why your answer is higher in semi-annual compounding as opposed to annual compounding. You have to retain this concept in your minds, that semi-annual, quarterly compoundings or monthly compoundings generate higher answers for future values as compared to your annual compoundings. Fine. So coming towards this will bring us to the second concept as well. But before moving towards this concept, let me highlight what about the present values. For present value, you'll again have to change the formula a bit. I've written this for your reference. If you have to calculate the present value, and in question it is mentioned that the compoundings are occurring or interest rate is applied semi-annually or quarterly, you have to again change your formula like this. You have to divide your interest rate by m, and you have to multiply your years by m. Fine. So moving on towards effective annual interest rates. I've already mentioned it in previous example that through your semi-annual compoundings, quarterly and monthly compoundings, you'll get higher answers compared to annual record compoundings. That's why your effective rate will change from the nominal rate. In the questions you are given the nominal rates. For instance, in this question, I've taken 10%. This is the nominal rate, nominal or ordinary rate which is applied. But what about you get higher answers instead of annual answers? So you have to calculate the effective rate for these calculations as well. For effective annual rate, it's you can only calculate this rate when your compounding is happening or occurring for more than once in a year. So for these effective annual rates, you will have to do this thing. Effective annual rate calculation formula is 1 plus I divided by m raised to power m minus 1. And you don't need any additional information for that. You'll use only the information of uh, interest rates and compounding periods in a year. Fine. For instance, if your 10% per annum rate is compounded semi-annually or is applied 2 times in a year, by dividing it 5% at the end of 6 months, and then again 5% at the other 6 months. So that makes it semi-annual compounding. When you will calculate the effective rate for this particular type, like the nominal rate is 10%, you have to calculate the effective rate. You'll use this calculation formula over here, and you'll insert 10%. You'll divide it by 2. If it was mentioned that it's quarterly compounding, you'll divide the 10% by 4. You have to take the power of 2, which is for semi-annual compounding. If it's quarterly, you'll take here 4. By solving it, you'll get 1.05 raised to power 2. which will give you 1.1025 in your calculators. You have to subtract 1 from this. You'll get 0.1025, or you can change it in percentage and you'll get 10.25%. That means a nominal rate of 10%, if applied twice in a year, will have an effective, or will be termed as, in effective terms, it can be termed as 10.25% of interest rate. Fine. So same goes with quarterly compounding. I've given given it as a reference. You can change the formula a bit. You can change the value of m. If it's written that it's a quarterly compounding and the nominal rate is 10%, you'll use this particular calculation and you'll get the answer of 10.38%. So you can see that as soon as the number of compounding in a year increases, for semi-annual, it increased from 10 to 10.25, and for quarterly, it increased even more from 10.25 to 10.38%. So the more the number of compoundings are involved in a year, the more will be this effective rate, and this effective rate represents that your value will increase even more. The actual value that is compounded, or in a year. Fine. So this will bring our topic to an end. We'll study the next topic in the next video, which is amortization of loan. So far, we have studied 4 different contents in this chapter. But for practice purpose, I have uploaded different questions on your portal. Don't confuse it with the assignment. The heading goes with by the name of assignment 2 or assignment 3. Assignment 2 is basically the list of questions from chapter 2. Assignment 3 is the list of questions from time value of money. You have to just simply solve those questions, and you have to share your answers with me, or you can share if you are having any problem in solving those questions. You can post it in our Google Classroom as well. It's not your assignment then again, because we are facing some problem because of the prevalent condition. I cannot take it in the hard form from you. That's why you can just take it as a practice session or solve those questions on your own and share with me if you are facing any problem in solving those questions. uh, I'll just end it here, our first video. Take it as the test video as well. If there are any issues or distortions in this video, I'll try my level best that the next video will be a refined version. So that's it. Thank you so much.